Hey team, it's Mr. Z, and we're going to finish up our mix review in order to get battle ready for the summative. Now, we're going to start to visualize, hey, can I get an idea of what this looks like in my head? Because it's just a bunch of equations. Let's dive on in. All right, number 11. Notice it's immediately in standard form. This is the same thing as saying 3x squared minus 7x plus 0. Sometimes it helps by writing out that last term in order to see that it's standard form, meaning that this guy is going to be a quadratic. And why? Standard form. You can also say that it is a degree 2, because the degree, the highest variable being raised, is 2, meaning it has 2 solutions. Oh, getting to our next guy. Scanning it. This is a degree 3, which means it's outside of my pay grade. It's going to be none of these. Here, the degree is x. This goes back to math 2. This is going to be exponential. The way I remember this is the x is in the exponential. The final guy, there's no number here. Remember, there's always an invisible 1. It is to the degree 1, which is linear. And some of you might remember it as f of x is equal to mx plus b. If you rewrite this top equation in a different order where you change the order of the terms, it resembles slope-intercept form. Okay, this next one. Simplify each pair of expressions and see if they are equivalent. So let me just go into my autopilot mode and math it up. This first one, I'm going to always write it out in expanded form, because this basically jumpstart my brain and tells me I need to FOIL this out. I clean up and combine like terms, and I get x squared plus 6x plus 5. This one on the right, I'm going to go ahead and multiply these binomials, and it turns into x squared plus 5x plus 1x plus 5, which this is false, not equal. Number 16 is exactly the same. Process it. Tell me, are those two terms exactly alike? All right, now for the coup de grace, the final bit. How much of a boss are you able to do? Now, on your reference guide, on a piece of paper when you're taking the test, remember, have your forms ready. Standard form is equal to ax squared plus bx plus c. Factored form is going to be equal to a times x minus root 1, x minus root 2. And the final one is vertex form, where it's a times x minus h squared plus k. Basically, analyze the form and see what we can pull. Number 17. This is in standard form. So I can tell you two things. A is 3. Most importantly, it's positive 3. It is concave up, and it has a minimum. The other piece of information I can tell you is that the y-intercept will be at the last value, negative 27. It is always 0c, so in this case, it's 0, negative 27. Number 18, even though it looks a little kooky, it is in standard form. Now, I know that a is equal to negative 2/3. I know it is going to be concave down. I also know it is going to be compressed vertically. Here, It has a vertex that is a maximum. And the final bit of information is about the y-intercept is going to be 0.32 is the y-intercept. Number 19. We're looking. This is totally going to be in vertex form. And I know that since it's in vertex form, it is always going to be 3, 12. Notice how it's x minus h. It is a positive 3. The h value is right here. The k value is here. I also know from my a being negative 72 that it is going to be concave down, and that this vertex is going to be a maximum. Wow, something a little different. This a value, though, being a big number, it is also going to be stretched vertically. Number 20, the form doesn't look too different. That's because it's a vertex form. Now my vertex is always going to be, if I rewrite this as k of x into 0.75, watch how I do it. X minus 12 squared minus 10. Writing this in this form helps me remember that the vertex of this guy is negative 12, negative 10. What do I know about it? Well, a is 0.75, which means it's a positive. It is going to be concave up. This vertex is going to be a vertex that is a minimum. And I also know that because it's a decimal, it is going to be compressed vertically because it's less than 1. You can see how I'm not answering every single bit. Now there is 2 bits that come from vertex form. The extension. I want you to make about 19 and 20. All right, so 19 and 20. Notice how we got the h, and right? There was this last bit from last week where it says the axis of symmetry, basically the line that cuts it in half, it is always going to be x equals h. So here it would be x is equal to 3. My axis of symmetry is always going to be the h value. X equals h. Therefore, it's going to be negative 12. Number 21 and 22, I leave you to have some fun and explore it yourself. So remember that last bit, and that's it for now.